and control unit. Are you ready?
Okay, let me share my PowerPoint.
Yes. Yes, please, your time.
Sorry. Okay, I think is it clear enough? Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. My name is Satyanto from IPB University. Today, I'd like to present our study from entitled Automatic Water Table Control System with Remote Telemetry and Control Unit. It's written by, as mentioned by the moderators, and we are collaborating between the university and also our alumni's own company specializing in instrumentation and such kind of technology. So shortly, the background of our study is that we would like to increase the economic, maybe we can call it value of paddy field, rice field, because you know that rice field is often being converted into other they think more profitable purposes, for example, housing and etc. So if we can introduce not only rice but higher having product with higher economic value, for example, organic rice or other product for example, horticulture or something like that, maybe there we can give some incentives, or it could be some incentives to preserve the rice field, not to be converted into other purposes. And the problem is we have sometimes we have challenge in water management. So in this case, we try to introduce the automatic system for controlling water table at the field, so we can do any kind of water management related cultivation, for example, flooded, non-flooded, organic, and etc. That is the purpose. So actually, the system had been studied or developed for the last 3 years, and this time I'd like to present only the model, lab model, but we run for about actually 1 year or more. But what I'd like to present here only for about 6 months. So we have water table sensors, water level sensors. We also connect the system to the internet, and we can control by using dashboard and in our laptop. Schematic of the system. So this is the model. Actually, we are developing the not lab scale, the field scale model near the EPB. But the systems actually we are using the subsurface perforated pipes to flow waters, and we control the water level by controlling water in this reservoir. And everything was connected, operated through the automatically, and can be set by using the internet connection. So we tried to operate the system automatically for about as I mentioned, about 1 year, but especially we try to use the system for corn cultivation, just for a small observation while we are observing the performance of our system. And at first, this is some figures how the water level, soil moisture, and rain fluctuates during the 6 months of observation. And we can see that the soil moisture fluctuates with the change of irrigation and drainage activities, also when it's rain. But during the 6 months, actually, well, this is maybe the challenge that always been faced while we are using the this kind of technology, data loss. So we still have challenge in fixing this condition. And this is the graphics. Actually, this 6 months data, but we how to say it? We accumulate. We conclude for 1 day. So we have the activities of irrigation with blue dots, and green dots is the activity of drainage. Means that at 1 day the irrigation and drainage valves will work. Were working alternately. Sometimes it's irrigate and sometimes drainage, like that. And so we can see this condition of water table. The orange dashed line is the upper limit of water table, and this one is the lower limit, and the yellow is the condition of water table during the operation. So somewhat we can successfully manage the water table, which in consequences we can also control the soil moisture, because the water will go up to the upper layer through the capillarity. So in this case, we are convinced enough that if we can use this system, then we can use the same field for example, flooded cultivation and unflooded cultivation, something like that. So hopefully, we do not need to rely only for rice, but also for other product that maybe at that times the economic value is higher than just rice. So we try to accumulate the irrigation, the drainage, and also the rainfall and the evapotranspiration. And this is the condition of corn, how to say, the corn during the cultivation. And we obtain that the water productivity, if we calculate based on evapotranspiration, is about 5 grams per liter. And if we calculate based on irrigation and rain, is about 1 gram per liter. Is somewhat smaller than they should be, but because it's just a side observation, maybe this enough for now. So the automatic control system for field water management has been developed using the perforated pipes and remote telemetry control unit, and it has shown good performance in managing water table and soil moisture, and it can provide good water conditions during corn cultivation. And the water productivity obtained based on this observation is 5 grams per liter over evapotranspiration and 1 gram per liter over irrigation and rain. Thank you very much. I return to the moderator.
Yeah. Thank you, Pak Satyanto. Nice presentation. Any question? Maybe Bu Anna can give your question for Pak Satyanto, because same water management.
Okay, ma'am. I want to ask you, may I ask you what kind of land type you apply this system? I mean, what kind this land that you apply this system applied in what kind of land? I mean, irrigation type or rain-fed rice field or swampland area? Which one?
May I answer?
Yes,
Okay.
please.
Okay, actually, I've been studying this kind of technology since my master degree about 22 years ago, I think. So at that time, we were focusing on peatland. So mostly drainage, not rainfed, but drainage. But in this, in the technology we are studying now, is actually we focus on water table. Water table is the saturated layer, water saturated layer in the soil. So regardless if it is rainfed or irrigated or drainage, what we are going to maintain is the water table. So whenever we need the water management that based on based on the management of water table, this can be used. For example, it can be used in, for now we are focusing on rice field, lowland, usual rice field, but also we can apply this to, for example, in lowland, I mean the tidal area. However, because this is the technology for the micro scale water management, first we have to manage the through the all part of irrigation command area, for example. So this is one part for, we can say maybe 1 or 2 hectares, maybe it's okay. But if we are talking about the one irrigation command area, we need to manage that part first. This is the macro scale. I think like that, Buwana.
Yep. I think this system applied in peatland area?
Not yet.
Oh, not yet.
But it's possible.
It's possible. Yes, because as we know, in peatland we must always maintain the water level. If not like that, it become irreversible drying. Is that right?
Yes, true.
Yes.
But because in wetland area, we are not talking about 1 or 2 hectares, not talking about 1 or 2 cubic meters of water. So before we apply this is only applicable for micro scale. So at the macro scale, we have to manage the area first, and within the area we can use this technology like that.
Because we can join to make a collaboration research. Okay, if you if you really to continue your experiment, we have because in our tidal swampland area, it's not so easy to maintain the water level because there are unpredictable flooding.
Yes.
It's because of affected from high tide and low tide, like something like that. Okay.
Yes. Yes. So management should start from macro scale first.
Yeah. Thank you very much for your explanation.
Thank you.
Yeah. Nice to hear that Bu Ana want to collaboration with Pak Satyo, BRIN and university, a good collaboration. Okay, any question? No? Thank you, Pak Satyada, for your nice presentation. Okay, next presenter. I call presenter with ID paper 18511. The authors,